Compared to the last example, this one's slightly different in that here we have had the denominators match in the top and bottom fraction. Here we have the numerators match in top and bottom fraction. And there is a simplification for this, but this is a little bit more complicated, so we should maybe go through the steps here. So I'm going to take a look at each factor again. So I have a factor A. That's a times factor, so I'm going to put that in the numerator. The C is definitely divide. And this second A is really a divide by A, so I'm going to put that in the bottom. And now I can see that those A's are going to end up canceling out. Lastly, the B is going to be a divide under the main divisor and another divide here. So divide, divide. So it ends up being times by B. And we can then cancel out the A factor. So these factors do cancel, but you have to be careful because now we have C's in the denominator, B's in the numerator. So this becomes B over C. So this one's a little bit more complicated. So maybe you have to be very careful with this one if you're going to use this one. Let's justify this one again. So it's going to be A over C divided by A over B. And we're going to convert that to A over C times B over A. Yeah, I can see that the A's cancel, and we end up with B over C. So the B in the denominator ends up in the numerator. The C down here is going to end up in the C in the numerator of the denominator of the numerator ends up in the denominator. So this one's a little bit tricky, so you have to be extra careful with that one. This one here has a plus in it, and pluses really mess up our factors because when we have a plus, we cannot consider it a factor. So that B is not a factor. So we need to make it a factor. So one way we can do this is we can make this into a common denominator and make this into one fraction in the denominator. That would do it. There's a much easier way we can simplify this though. And essentially what I want to do is I want to get rid of the times D in the denominator with multiply by D in the top. And to balance the fraction, I need to multiply by D in the numerator. So notice that this is D over D in the top numerator and the bottom denominator. That's going to give us a ratio of 1, so that will keep our fraction the same value. And in doing that, we're going to end up with AD on the top. We're going to multiply D times B. And when we multiply the C over D times D, to divide D times D in the denominator, these cancel out and we're just left with plus C. So now we have one factor in the numerator, and as long as we keep that all in one group, that's one factor in the denominator, and that's our simplified fraction. And again, please make sure we're not doing some things like this where we cancel this and this. These are not, this is a factor. This D down here is not a factor because of that plus, so we can never do things like that. So that's our justification, that's our simplification. That's the easy way to do it. We can also make this into a times divide, and we can just test out our pieces like this. We can just make our denominator into BD over D, that's same as B, plus C over D, and then that's going to give us one denominator. So that works out to be A over BD plus C all over D. That's my main divisor. So this is times A, divide by BD plus C, divide by D. So then that D really ends up in the numerator as AD over BD plus C. So either way we do it, we get the same thing. But this strategy here of getting rid of the times in an embedded fraction by multiplying through and balancing the ratio is one way to, it's an easier way to deal with this type of complex fraction.